Select the major product or products of the following reaction. So looking at this reaction, we see that the starting material is an alcohol, and specifically it is an alcohol that the alpha carbon of the alcohol has bonds to 1, 2, 3 other carbon atoms. So this is a tertiary alcohol. And we are reacting this with hydrobromic acid, which is a very strong acid. So to predict the product of this, I am going to draw the mechanism of the reaction. So here is the tertiary alcohol. And so we should notice that this alcohol has a stereocenter. And looking just briefly at the options, it appears that we really do need to consider the stereochemistry of this reaction. Okay, so there is our alcohol. And these lone pairs of electrons on the oxygen can function as a base or as a nucleophile. And since we're reacting it with a strong acid, these are going to function as a base. So let me draw the HBr. And so the first step of this reaction is going to be this tertiary alcohol acting as a base and reacting with the hydrobromic acid, which is a strong acid. And so after this acid-base reaction, what we will see is we've protonated that alcohol. So we could also call that first step a proton transfer step. And what we've done is we've made something that is now a really good leaving group. So good leaving groups are things that once they leave are either neutral or very weakly basic, right? So the bromide that we're losing here, being the conjugate base of a strong acid, is also a good leaving group. We saw that in the alkyl halide chapter. And now this will leave as a water molecule. So this would also be a really good leaving group. And so the reaction that's taking place is going to be a substitution reaction. So to decide if it's Sn1 or Sn2, we need to think about the structure of the substrate. And since this is tertiary, we are going to be looking at the Sn1 pathway. So that means that what will happen here is that the leaving group will leave and we will form a carbocation. So there is the carbocation. And it's important to note that that carbocation carbon is, so the one right in there, is sp2 hybridized, which means that it is trigonal planar. And this is also a very strong electrophile, a carbon with a positive charge. And so this trigonal planar electrophile can be attacked on either side by a nucleophile. And we freed up some bromide ion here. So we have bromide ion in solution. And this bromide ion can basically attack from either side of that flat carbocation. And so what that's going to lead to is a mix of stereoisomers. And so that means that the right answer to this, the bromide is going to bond. And so we're really looking at between B and D. And B is where we see the bromide has attacked from either side. So that is the right answer for this problem.